Okay, so very good morning to all of you. And we will be proceeding our previous lecture. In last lecture, we talked about spin, and we stated the states of a spin as spin up and spin down. So we chose a spin up like this, and the state for spin down was chosen like this, right? And then what we did, we wrote down the components of the spin. We wrote down Ix and Iy, right? So in case of, because you can have these two states of spin along the components. I mean, you can have, if you talk about 2 dimensions or 3 dimensions, you have x, you have y, and you have z, okay? So for z, you will have opposite z. For x, you will have opposite x. For y, you will have opposite y. Getting my point? So then we stated something like this: spin up as along x. This is what we defined. And we defined it as a column vector of 1 by root 2 and 1 by root 2. So this is our ket of spin x, right? And if this is the ket of the spin x, if you translate your ket into a bra, your column will change into a row matrix. But since we have irrational numbers here, we don't have a complex number, we don't have to take a complex conjugate in this case. So you will have spin down along x as a row matrix of 1 by root 2 and 1 by root 2. Fine? Okay? So similarly, so this problem we resolved. If you rightly remember, we obtained sigma x from it. Now the next thing is, let's choose our spin along y. Now this has to be chosen as 1 by root 2 I by root 2, and its bra is a row matrix of 1 by root 2. Now here you can see a complex thing. So you will have to write the negative of this I, okay? So here you will have 1 by root 2, then you will have minus I by root 2. Fine? Clear? Now, what is my aim? My aim is I want to generate my sigma y, okay? So for that, I will come up with a state, okay? I will come up with the system. So, what will I do? I'll take an external product of sigma y, spin up y, and spin up y. So this is your ket and this is your bra. And then you take minus, spin down y, and spin down y. Is this clear? See, it's purely symmetrical. The way we resolve the spin along x, we are resolving it along y. Okay, now we can do it. So for the ket of spin up along y, I have this thing. 1 by root 2, then 1 by root 2. So for this, you have a column matrix, and here I have to have iota. Okay. And then here I will have 1 by root 2 minus I by root 2. It has to be like this. Fine? Okay, then moving on, I'll have minus down. So for down, I have 1 by root 2. Then I have minus I by root 2. So this is your column vector. And then you'll multiply it with the row vector 1 by root 2 plus I by root 2. Because here you have minus I by root 2. You have to take its complex conjugate. So it will go to plus I by root 2. Clear? Now let's solve it. Okay, so now let's solve it. So what you'll get 1 by 2 here, then you'll get minus I by 2, am I right? Okay, then you'll get I by 2 for this, and iota square will give us minus 1, that will be multiplied by minus, that will become plus, so here I'll have 1 by 2. Fine? Right? So I will have my own negative sign here again, so I'll go with the multiplication, you will have 1 by 2 here, then you will have I by 2 here, then you will have minus, it has to be minus I by 2 here, then you will have again plus, okay? So you will have 1 by 2 here. Fine? Now all you have to do is to subtract the two matrices. Okay? So 1 by 2 minus 1 by 2 will give us, it will give us 0. And minus 1 by 2, minus 1 by 2 will give me minus I, right? So here I will have minus I. Then I by 2 minus, then you have minus. You multiply this minus with this minus, it will become plus, so you will have I here. And finally, I will have 1 by 2 minus 1 by 2 will lead us to 0. Now this is your well-known sigma y. So this is your another component of the Pauli's matrix, as sigma y is 0 minus I, and a 0. So you will be using the same tactics to calculate sigma z.
सर वहाँ तो 0 बनेगा ना, माइनस आयोटा बाई 2 को जब हम माइनस करेंगे तो ये 2s बनेगा. ठीक है मुझे कंफ्यूजन था, हो गया क्लियर.
Now it's over. You understand it? Okay, fine. So this is it. Okay. Now let's talk about probabilities basically. See, in quantum mechanics, what we do is when we make certain calculations, we make certain predictions, and these predictions always tell us about the probabilities, which is not the case in classical world. In classical world, you do everything in the framework of accurate predictions. Now, what do you mean by that? That means, suppose I have a coin, okay? I'll ask you a simple question. I have a coin. If I flip this coin, can I predict what will be the outcome of the coin? You are saying yes. You are saying yes. Okay, so what's the reason? It will be, so you are giving me the answer in terms of the classical probability. You are telling me that there is a probability equal to half. But I am telling you, do the laws of physics allow us, the classical laws of physics, because coin is a classical object, do the laws of physics allow us to predict what will be the outcome of this toss? The probability that you are talking here is not the quantum mechanical probability. This is a classical probability. The answer is yes. You can accurately predict what will be the outcome of the shot, provided you are able to calculate all the parameters classically. The parameters, what's the material this coin is made of? How does this coin will interact with the air present in your system? With what force you will flip it? If you will use all of these calculations, which is not possible in real sense, but if you will use all these calculations, you will accurately predict the outcome of your action in the classical world. This is what I was trying to tell you. But that's not the case. That's not the case in quantum world. In quantum world, you have to live with these probabilities. The electron has a probability of being here 70%, Here it has 60%, here it has 40%, here it has 10%. What does it mean? If we go in the framework of quantum mechanics, it means electron is there. With all these probabilities, it's here, it's here, it's here, it's here. Getting my point? But the moment you will try to measure it, the moment you will try to measure it using an experimental device, the wave function that you have generated, it will collapse. And you will find one state. You will find your particle in one of these all probabilities. Getting my point? Right? So now we want to move on. Let us take a problem and try to calculate the probability of having some spin along, say, positive of x, a spin along the downside of x, right? So to do that, let's choose a problem. Come on. So, let me choose a state vector. Say I will choose a state vector zeta. Let's assume that I have a state vector zeta. And this state vector is given by 3 by 5 plus I 4 by 5. Now, I want to calculate the spin. I want to calculate the probability that the spin of the particle in this eigenstate has to be along the up direction of x, has to be along the down direction of x. So what am I trying to do is, I am operating on this state by, say, spin up along x. So my question is, what's the probability that the spin will be along up in x direction? Okay? So, how do you calculate your probabilities? How do you calculate your probabilities? You have an eigenstate, okay? You operate it. If you have an operator, then you take the probability amplitude. You multiply your state with its counterpart, and that gives you the measure of probability, right? So here, if I take on, this is my state zeta, right? This is my state zeta, and this is what is my spin up along x? Yeah, what is it? It is 1 by root 2, 1 by root 2. Now, if I change this cat into the bra, what it will become? It will become spin up x is the row of 1 by root 2 and 1 by root 2. Is this clear? Now, I want to calculate the interaction. Okay? I want to calculate the bra of this spin up and the cat of this. Now, what will be the cat of this zeta? It will be a column vector. It will be a column. So I can write down this zeta as the column vector of 3 by 5 and I 4 by 5. Are you getting it? Okay? So now let me calculate the inner product. Just come on. Why you are late? I have seen you first time. Come on, sit down. Okay. So what you are going to do is, you are going to calculate the inner product between the spin up and zeta. So what will be that? That will be spin up and zeta. Right? Now calculate this. How you will calculate this? Now what is bra of spin up along x? That is 1 by root 2 and 1 by root 2. So this is 1 by root 2, 1 by root 2. And for the cat of zeta, I have 3 by 5 and iota 4 by 5. Are you getting? So come on, multiply. What you'll get? You will get 3 by 5 root 2. 3 by 5 root 2. This will be term number 1. Then you will have plus 4 iota by 5 root 2. 4I by 5 root 2. Is this clear? Is this clear? Fine? Okay. So what I have obtained, I have obtained my spin up along x acting on state vector sub zeta, leading me 3 by 5 root 2 and 4I by 5 root 2. What is my question? Come on. What I want to calculate? I want to calculate the probability. What's the probability that the particle will have spin up along x component? That's my question. That's what I'm trying to calculate, right? So, come on. How will I calculate that now? Come on. Of course, I will take the square. Okay, but this square it's not the ordinary square, it's a square of complex. Okay, you have a complex thing, you will multiply this complex thing with its complex conjugate. So when you will take the square of your system, you just take it positive because you take the mode of that. Because you understand that everything comes out to be positive when you calculate the probability density. So, come on. So what will be that? That will be, so let me define that probability of getting spin up. Come on. Probability of getting spin up. Yeah, what will be that? That will be simply, if I define that as P spin up, okay? That will be simply what? That will be matrix of sigma of x and zeta whole square. Right? What this is going to give me? The probability that the spin of this particle is along the positive direction of x. Right? So, I have already calculated this inner product. What's that? That is 3 by 5 root 2. So this is 3 by 5 root 2. Then plus 4I by 5 root 2 whole square. Clear? Is this clear? Now this is done. So what you will get out of it? Okay, you see 5 square root 2 square will be out. Okay? So probability of getting spin up. So it will be 1 by 25 root 2 square. Am I right? Am I right? So what will be inside? The mod, you will have 3 square plus 4.
9 here.
This is 3 square plus 4I square. No, I should write it like this because whole square. Okay, it's like this. Okay, you will get here. What you will get here? This is 3 square 9 plus. It will become plus because you are taking the complex conjugate. So you will get 25. You will get 25. So P spin up will lead me. Square and root will cancel. So here what I'll get 1 by 50. Here I'll get 25. Am I right? So this is 25. 1s are 25, 2s are. So I'll get 1 by 2. So probability of getting your spin up is how much? It's 1 by 2. Right? Come on, solve the next part of it now. Yeah, what will be the next part? I want you to calculate the probability of getting spin down along x. Okay? So we can do that. Now we have to calculate the probability of getting spin down. Okay, shall I rub this or shall I wait? Come on. If anybody has any curiosity, you can talk about that. Yes. Come on. Yes. Because this is the ket of z, so you can choose it as zeta. Okay? So this is ket of zeta is column. Zeta is a vector. Okay, when you write down the, if you write down the state of zeta, okay? When you write a ket, what do you mean by ket? It can be anything, okay? You can write down it in terms of the column vector. So I'm writing this thing as a column of this zeta. Okay? So I wrote down the column of this value that is given for this. Now, shall I show you the next part or you do it? Now let's go with it, okay? So now what's the next thing that we want to calculate? Have you copied it down now? Okay, now let's go with so now I have spin down along x. That is a row vector of 1 by root 2 and 1 by root 2. Am I right? It is a? Oh no.
नहीं ठीक है वो y के लिए ये x के लिए ठीक है.
That's for y, this is x. Okay. And then you have this thing defined already. Now you can calculate sigma spin down along x and zeta. And this will give us what? It has to be minus, I think. Come on. No, it has not to be minus. It has to be plus. Okay? So this is 1 by root 2. 1 by root 2. Come on.
नहीं कॉलम में नहीं आएगा वो y आएगा. y आएगा तो अलग है. सर आपने अभी दिखाया ना ये.
Yes.
आपने भी लिखवाया नहीं.
स्पीक एक्स मतलब दो वर्ड है सर. ये आपने कैट में लिखा आगे रो में लिखा है. ये कॉलम में आएगा.
You mean to say this will come in?
ऊपर कैट ऑफ स्पिन डाउन.
Ket of spin down?
ये कॉलम में आएगा.
No, it will come in row. You check your copy.
सर ये ठीक है. अभी आपने दिखाया ना ये ठीक है.
You check it. Come on. I have taken it as a ket. I have taken, but its bra will be a row, na? I'm writing a bra here. Yeah, what's wrong with you? Okay, I have written it ket here. I have to write. I'm writing its bra. Here I'm writing it wrongly. I have to write a column here. You are right. You are right. Okay, so you will rectify that in yourself. Okay, then you will have to multiply this. Okay, right? And what you will get? Come on. You will multiply this with. This will be 3 by 5, and this will be I 4 by 5. Yeah.
Minus 1 by root 2
There. Yes. No. It doesn't have iota with it. How you can have minus?
सर वो y के लिए आएगा,
हाँ?
y के लिए है,
डाउन लेंगे ना 1/√2 minus 1/√2.
We started with that argument, and then it has to be minus. Yes. Yes. Because for spin up we take both the positive. Okay. Then for spin down I take one positive and another is negative. So here I have to have a negative of 1/√2. That's fine. Okay. That was a pure mistake we committed. Okay. So we have to include here negative sign. Clear? So let's multiply it back now. Okay. What you will get? You will get 3/5√2. So I think I should rub this part. So what I'll have is, so spin down on x, then you will have zeta. This will give us 3/5√2. 3/5√2. And the another one will give us minus 4/5√2. Minus 4i/5√2. And you are going to have this thing. And if you want to calculate the probability of getting spin down along x, for that, you know what you have to do. So you have to take the square of it and then take the mod. So you will have, if I define this probability along x in the downward direction as p, that I can write down as spin down along x, and zeta, this whole square, will give me the probability for this spin to be in the other direction. So come on, calculate this now. So what you will have, 1/25 is out, and √2 and square will cancel. So this will be times 2 is out. So inside you will be left with 9. Yes? Plus. See, we have. No, it will not come. It will never come the same. It has to. Come on, we are committing some. Now here I have minus. In the previous case? Yeah, come on. So? So, this is my minus. No, it will not come like that. It has 4i, and you have to multiply this with 9 plus 4i. That's it. This is how we have to multiply it. No? Now, this is 1/50.
3 आएगा 3 minus 4 आएगा 8 plus 4.
Oh, yeah. This is 3 minus 4i, and this is 3 plus 4i. So this is, come on. So this will give us 9. This will give us plus. Okay. Plus. Something wrong has happened, I think. Yes, you know what has happened? Come on. This is. This is 12, and then 16. Yes, that's fine. Okay, now look at this. Okay, this is 3 3s are 9, fine. Okay, then 3 4s are 12. This is 12i. Anything wrong with it? No. Then you have minus. No, I am multiplying this 3 with 4. Okay, so then 4 3s are 12. This is 12i. Okay, now 4 4s are 16. Okay, so again, but the sign outside is minus. So iota square is minus, so it will make it plus. Something is happening wrong somewhere. Come on, you check it. Something is happening wrong. Maybe we are. 3 minus 4i. Come on. What was the result in the previous case? No, I'm talking about it was 3 minus 4 iota there. What was it? It was 3 plus 4 iota. Right? It was 3 plus. So, what is it that is missing in our solution?
सर ठीक है पता है क्या है वहाँ पे प्लस जो है अगर वहाँ पे प्लस आएगा 4 प्लस 4 आयोटा आएगा जब हम इसका मॉड लेंगे तो वहाँ पर 25 तो बनेगा लेकिन जो आयोटा है उसको भी स्क्वायर बनेगा वहाँ पर माइनस बनेगा और लगभग कहाँ से आएगा शायद 9
See, we are multiplying this. Oh yes. Come on, this is square, nah?
So is square minus b square.
No, then there is a problem that way. No, you see, this is 3 square. See how it has to be done. I think that will be the most probable way of doing it. This will be 3 square. Let's give the square to this. And this will be 4 square. Iota is not going to die here. No? Iota will die only when I will take the whole square. Come on, something is wrong. I think this is right. For x, in this case for x, we will check it later on, okay? For now, we are getting the same result. We are getting the same result for what? Probability of getting spin down, we are getting as 1 by 2. Now let's go with probability of getting spin up along y. Let's do that, okay? Probability of getting spin up along y. So here we are getting 1 by 2. Yes. Okay. So what is your spin up along y? Come on, what's that? Spin up along y is 1 by root 2 and I by root 2. Am I right? Yes. But I need for my inner product, I need the bra of spin up along y. So what will be the bra of spin up along y? This will be a row of 1 by root 2 and I by root 2. I think that the previous solution was correct. I think it was not wrong. Let's see. Okay, so this is our I, this is our spin up along y, okay? Now what will I do is, I will take the inner product of this, spin up along y with zeta. So what will be that? That will be spin up along y and you will have zeta. Is this clear? So this thing is known to us. What is that? This is 1 by root 2. Then you have I by root 2. And then you have the column vector for this zeta. What's that? That is 3 by 5 and 4 iota by 5. Isn't it?
Minus.
Okay, yes. Don't be so excited. This has to be minus. That's fine, okay? This has to be minus. Now come on, let's solve this. And calculate the probability of having spin up along y. Come on, do it. So here you will see here, you will have 1 by 2, that is 3 by 5 2. 3 by 5 root 2. The next term will be what? 4 iota square will give us minus 1. And minus will become plus. So this will become plus 4 This is 4 divided by 5 root 2. The previous thing that we have done was accurate, nothing wrong with that, okay? We were trying to, because I was maybe confused with, because I thought that I'm in the domain of a spin along y. Now what we have to do is we have to calculate the probability of having spin up in the y direction. That's our job. So that's this. So for that, I'll be writing that probability as P up along y. So what will be that now?
1 by 2.
That will be square of this. 3 by 5 root 2 plus 4 by 5 root 2 whole square.
1 by 2.
No, it will not come as 1 by 2. Okay, so you check this, what will be out? Out you will have 25 times 2 will be out. Get it? 3 plus 4 is how much? It is 7. And you have to take the square of 7. So that is 49. And that's the beauty of solving a problem. Okay? So what I'm getting 49 by 50. Come on. So this will be your probability of calculating the spin along the positive direction of y. Are you getting it? So what is 49 by 50? How much is this? It is 0 point. No. 0.98. In the previous case, when we solved the same problem along the x, what was the probability? The probability was 0.5. Okay? And now you calculate this. Come on, 0 point, is it coming 0.98? So this will be your probability when you will measure the spin along the positive direction of y. Are you getting my point? So you can proceed with the same calculations to calculate the probability of having spin down along y. Getting my point? So this is how we have, this is a new analytical way of solving the problem, a very primary kind of thing we have used. What we have done is we have chosen a state vector, then we operated this state vector with the seconds. We acted the spin up state, and then we acted it with the spin down state, and then we tried to calculate the probabilities for having spin in positive direction and negative direction with respect to the components of these spins. Is this clear to you? You want to tell me anything? Okay, so with this we'll stop here.